Hello students, today we are in lecture number 10 of standard 11 and we will study today very important topic. I am BS Pandey, my dear student. Here we go in lecture number 10, okay, of unit vector analysis. Okay, we will study about the vector analysis. So student, today we will study the concept of magnitude and direction. Magnitude and direction of resultant, okay, using triangle law. Using triangle law of vector addition. Here, student, suppose we are having two vectors. One is this one, suppose the vector A, and another vector, it is vector B. The magnitude of magnitude of vector A is A, magnitude of vector B is B. Alright, and this is the resultant of these two vector. This is our resultant. I hope you understand. And the resultant having the magnitude capital R itself. Now, could you search the angle between vector A and B, my dear students? Since the head of A is over here and of B over here. Here the head of A and tail of B. So you cannot write this is the angle between two vectors. It means you have to proceed this vector to find the angle, and this will be the theta angle between vector A and B. I hope you understand. You will proceed this vector, then head will over here, head will come to this, and then you will find the angle between. Now for both the vector, tail is here, okay. Now theta is angle between vector A and B. Okay, I'm writing another angle, alpha. Could you tell me this alpha is angle between which and which vector? So this alpha is the angle between yes, R and A, because R and A having both the tail over here. Vector R and A. Actually we have to find this alpha also. Okay, theta is given, magnitude of AB is given. Okay, let me draw a perpendicular from this point. What we have to find? We have to find magnitude of this R and direction of this R with this vector A. Okay, suppose this is X and Y axis. This is very important. This is Y and this is X. So this vector A is along X axis. It is very clear, you can see. My dear students, let me write this O, this is P, this is Q, this is M. In triangle OQM, directly you can get the value of this OM using Pythagoras theorem. Okay, using Pythagoras theorem in triangle OQM, what you can write? You can write OM square is equals to OQ square plus QM square. Yes sir, we can write. Very good. Now, do you have the value of OQ? OQ, no, you don't have. Actually, what is OQ? So you can see this QM square. Oh no, it is OM. No? Yes, OM square. It is OQ is OP plus PQ. Can we write OP plus PQ? Yes, we can write whole square plus QM square. Now, do you have value of OP? Yes. Do you have value of PQ? No. So, try to remember the component method. You can break this B in two components. One on this axis and another the perpendicular this axis, which is equals to this QM. So this will have the two component. One, it is B cos theta, and here it will be B sin theta. B sin theta. I am using the magnitude. Alright, here B, I am using the magnitude B because this vector having the magnitude B. Now we are having the value of all the sides. Proceed from here again. It is OM square. What is the OM? It is OMR. Remember, everywhere we are using only magnitude. Only magnitude. We don't require to write here the direction. So this is the R square is equals to, okay, R square is equals to OP. It is A plus PQ. It is B cos theta. B cos theta whole square, alright, plus QM. So QM is B sin theta, B sin theta whole square. Yes. Now solve this. A square plus B square cos square theta plus 2AB cos theta plus this one B square sin square theta. Now this is A square. You can see B square here cos square theta and B square here sin square theta. Common will be B square and sin square theta plus cos square theta will be 1 plus remaining 2AB cos theta. And what is this? It is R square. It means R can be written as root under A square plus B square plus 2AB cos theta. Very simple. And this is the magnitude of resultant of two vectors. My dear students, this is the required answer. That is the magnitude of resultant of two vectors. Now we will change the vector. We will change the orientation of the vector A, B. We will change and then we will find what should be the proper magnitude. But remember, the magnitude for the two vector inclined at theta angle will be R is equals to root under A square plus B square plus twice AB cos theta. Remember, this is very important, my dear student. Now we are going to find here the direction and then we'll proceed for few more interesting results. Okay, let me wrap this one here. Kind of note down. You can pause the video and you can note down. All right. Yes. Here. Now the direction. In mathematics or physics, the direction we always try to represent by the tangent. Okay, it means we have to find the tangent and we are going to find the direction of resultant with the vector A. Remember, this vector A is along the x-axis. So you can say that we are going to find the direction of resultant with the x-axis also. Alright, yes. So here the direction of resultant, let me write directly, you can write, I'm telling the direction of resultant. Okay, so it is tangent. Which angle? Alpha. Tan alpha. Could you write, my dear student, tan alpha? Yes, in this triangle, again, tan alpha is perpendicular, yes, it is B by H, P by B, and the perpendicular it is which one? The perpendicular for the tan alpha we can write it is QM by base, P by B, base, it is OQ, and we can write this as QM divided by base, it is OQ, it is OP plus PQ, OP plus PQ. Okay, now here the tan alpha is QM. QM, what is this? B sine theta divided by OP, it is A plus PQ, B cos theta. This will be the formula for the direction of resultant. Okay, so we'll use two formula here we are having for the magnitude of resultant, for the direction of resultant. This is alpha. This alpha can be also written as tan inverse B sine theta over A plus B cos theta. Okay, now let me discuss here few important points. I'm going to orient. Okay, what will be the maximum value, what will be the minimum value, what will be the condition if the two vectors are inclined at certain angles. Okay, so this will be our case 1. Let me rub this one, you have removed already. Now case 1, if theta is 0 degree, we'll write the magnitude and direction as well. Alright, yes, if theta is 0 degree, what is this theta? Angle between two vectors. One vector A was this one, B was this one, and theta with this axis. So if theta is 0, then B will move down, this B. What will the magnitude? If both vectors are on the same line, that is the parallel vectors, then the magnitude simply added. Okay, simply added. If they have no particular angle, that is the 0 degree, then they simply added. So the resultant magnitude will be A plus B. You can find out by the formula also. Alright, here R is equals to A square plus B square plus twice AB cos theta, and it is cos 0 degree. Okay, it will be, sorry, cos 0, no? It will be 1. So A plus B whole square root under A plus B whole square, and all together we are having A plus B. So you can see the resultant, and remember this is the maximum resultant. This is quite obvious, my dear friends. If you are having two pen like this one, in what manner you will get the maximum length using this two pen? Simply this one. Okay, simply you can add this two pen in this one only to get the maximum. Okay, now if you will add this two pen in this way, remember I have added this two pen, this is the head and this is the head of this two pen. If we'll add the two pen in this way, okay, 180 degree, then what will be the length? Remember, you always represent the two vector. Here we are using triangle law, so this is not the right representation. One vector, it is end over here, the second should be start from there. Okay, so like this one. So what will be the resultant? You will find if this pen is little smaller. Okay, look at here, I'm just pulling that back. You don't have to look over here. Suppose this pen is a little smaller, then this will be the resultant. So you are getting this very small resultant. Okay, this one is a very small, this one. Okay, so this one is the very small resultant. In this case, the resultant will be very small. Here, if the two vectors are in the same direction, let me represent the resultant by the red marker, and this is the resultant. You can see it is the ordinary sum of the two. What will be the direction? Tan alpha you will get, it is 0, so the alpha will be 0. Of course, this is not making an angle with A. Both are parallel, A and resultant, so the angle will be 0. You can put the value here, theta equals to 0 degree, you will get the answer. Alpha is 0. Alright, yes, here the sign 0 will be 0 and altogether 0, so the alpha will be 0. Now, the second case. case 2. Remember, this is the maximum resultant. You can have maximum A plus B, not more than that. Now, the next case, it is if theta is 180 degree. Okay, 180 degree. So the one vector looks like this one, A, and B. This was the B. If this was the B, if you move like this way, the angle is decreasing, but if you will move in this way, the angle become 90 degree. If you move again, the angle is 135, 40, 50, 60, 70 and 80. So the 180 degree I have to put here. So 180 degree. Okay, I have made here A is little longer, B is shorter. Okay, so this will be the resultant. Look at carefully. This is the resultant. Okay, this is the R. Why? The two vector, the resultant should be head to head. So this is the resultant. What will be happen if the magnitude of A and B both are same? The resultant will be 0. Alright. But here in this case, you will get the resultant. It is R is equals to root under A square plus B square plus twice AB cos 180. Alright, and it is minus 1. So A minus B whole square root under, you can write the root in this way also, power 1 by 2, and it is how much? It is A minus B. So the resultant magnitude is A minus B. Remember, this is the minimum value. You cannot obtain the minimum resultant from this one. This one is the minimum. Using this two vector, you can get the minimum if you add this two vector in anti-parallel. Remember, so this is the minimum. Suppose I am giving you the two vectors, a 7 Newton, a 3 Newton, and I ask what will be the probable vector, that is maximum and minimum. One is 7 Newton and the second is 2 Newton. Now I'm asking the question, could you find the resultant of this two at any angle? Whatever you want to put the angle, you can incline. Okay, can you find the net resultant 8 Newton from here? The answer is no. Yes, sorry. Could you find the resultant here, the 11 Newton? The answer is no, we cannot find. What should be the maximum resultant? It is 7 to 9. And what should be the minimum? It is 7 minus 2, it is 5. If someone asking, could you find 11 Newton? Answer is no. If someone asking, could you find here the 2 Newton? The resultant is 2 Newton. Answer is no. Because we can obtain here 7 minus 2 minimum 5 and maximum 7 plus 2 it is 9. Okay, my dear students. So remember, the two vector will give you maximum and minimum. The limits between these two values you can have the results. Now the next case number 3. This is the very important, my dear students. Remember, case 3. If theta is 90 degree, okay, like this one, vector A and vector B, you can see the angle between these two is 90 degree. So this will be the resultant, na? Yes, this will be the resultant, R. So what will be the magnitude of resultant here? The R is root under A square plus B square plus twice AB, and cos 90 is how much? It is 0. So the resultant magnitude is A square plus B square root under. The very simple. If you add the two vectors which are perpendicular to each other, the resultant will root under A square plus B square. You can recall the Pythagoras theorem. Actually, this Pythagoras theorem gives this hypotenuse. It is a square and b square also. So vector is completely right. Now the direction of resultant. Okay, so you have to pay attention over here, my dear students. The topic I'm going to deal here now, this is very important for the relative velocity. You will use the direction by this one only. Okay, so let me draw this one again. This is the vector going towards which axis? Suppose x-axis. So let me write this x, and this vector is going towards which axis? It is b along, this is y suppose, and this is x, this is y, and this is a resultant. All right, this is a resultant. Now I'm going to find out the direction of resultant here, suppose the theta, with the x-axis first, with the x-axis. Okay, so I'll give you the short method also to remember directly how to find the resultant. Okay, now let me write here tan alpha. I'll use this black marker, much better visibility. Tan theta we are going to find with the x-axis. Okay, I'm going to put the values in this equation. B, what I have to write, B is y now. Okay, so y sine 90, all right, divided by a, it is x, plus b cos 90. Cos 90 will 0, and this will be the x, and this is 1, so the y by x. Tan theta, it is y by x. Very important. That is, theta is tan inverse y by x. Now trick to remember this one, my dear students. Trick to remember this one. Look at here carefully. You are finding here the tan theta, and the theta is the angle of resultant with which axis? X-axis. And you got x down, okay, as denominator. This trick is only applicable for the vectors if both are inclined at 90 degree, and in relative velocity you use always the vectors at 90 degree. That's why I am giving you this one, and you have to remember in that section of relative velocity I'll ask this one also. Okay, I will teach you all the topics that you have to study in standard 11 in my sequence. Remember, what sequence it is given in NCERT, it doesn't matter, because if I'll teach you with the sequence of NCERT, remember there will be a very blunder. That will be the blunder, because the concept you have to use in the second chapter, it is to be studied in chapter number 4, like this one. You have to study this vector in chapter number 4, and you have to apply this one in your kinematics, which is in chapter number 2. Okay, now tan theta, it is y by x. All right, here if you are finding the angle with the x-axis, so x will be down. If you find the angle with y-axis, then y will be down. Here I am writing, look at the board. Tan theta, it is y by x, and here we are finding the angle with which axis? With x-axis. This is the trick you have to remember. If tan theta, I'll write x by y, then with which axis I'm going to measure the angle? Theta is with y-axis. Okay, with y-axis. If you have to find the angle with y-axis, then you will write x by y. You have to find the angle with x-axis, then you will write y by x. The angle you need to find with which axis, that quantity will be as denominator. Must remember this one. Okay, now I can reduce this one to the parallelogram law also, using this parallelogram. This is x, and this y could be here, and this is the resultant. Alright, so if this is theta, then what will be? Y by x or x by y? If this is theta, then yes, y by x. If this is theta, then which will be x by y or y by x? Yes, x by y. It means this resultant making an angle theta with x, then y by x. If this resultant making the angle with this, then it will be the x by y. Using mathematics, you can also correlate this one. This is not very big deal. Okay, now over this 90-degree case of 90-degree, we should do some practice, my dear student. The two vector, all right, the two vector, if the two vector are inclined at 90-degree, the resultant, it is the magnitude of resultant is root under a square plus b square, the x square plus y square. Suppose you move x unit along x-axis and then y unit along y-axis. What will be the resultant here? The resultant will be xi, okay, plus yj. And what will the magnitude of this resultant, my dear students? It will be x square plus y square. Very simple, na? If you are having the question of vector is a represented by 2i plus 3j, okay, what will the magnitude of this a? So the magnitude will be, here the mod of vector a will be how much? Yes, it is 4 plus 9. Very simple, na? Root under 13. Okay, so you can write this is as root under 13, my dear student. For 3 axis, if 3 axis we are using, okay, for position vector we will discuss in very detail, but let me tell you over here, x, y, z. If this is a point in space, coordinate x, y, z, then what will be the magnitude of this position vector OP? So this OP can be written as xi plus yj plus zk, and magnitude of OP, you should remember, it is root under x square plus y square plus z square. In the same way, alright, if the 2 are at 90 degree, then x square plus y square. If 3 are at 90 degree, then x square plus y square plus z square. You have to remember. So here I am going to solve few question. Kindly note down. Yes. Suppose if you are having a vector like this one, vector A, it is 2i plus j plus 2k. What will be the magnitude of this vector A? Yes, it is root under 4 plus 1 plus 4. That is 9. That is 3. Very simple answer. Okay. Now, if the vector is, let me generalize this one. If the vector is xi plus yj plus zk, what will the magnitude? Magnitude will be root under x square plus y square plus z square. Okay. Now, if the vector is a equals to xi minus yj minus zk, then what will be the magnitude? So the magnitude of this resultant A will be, here the coefficient of I is plus x, so the x square. Coefficient of j, it is minus y, so the minus y whole square. And coefficient of k is minus z, so minus z square. So there is no such change, it remains same, x square plus y square plus z square. Sometimes student do mistakes. What they write? Actually they put negative over here because it is negative. Remember, my dear student, minus goes with the magnitude, so it is the minus and we do the whole square, and then minus whole square it become plus already. Okay, so there is no very big change, but direction will change. Okay, now one more. If A is 2i plus 3j, what will be the magnitude? So the magnitude, it will be 4 plus 9. But if A is 2i minus 3j. What will be the magnitude? It remain 4 plus 9. No change. But how you will represent this two vector? We will discuss this particular thing in next lecture in very detail. 2 plus 3 will look like this one. How, sir? 2 unit along x-axis and 3 unit along y-axis. So this will be the resultant, na? But this one 2i minus 3j, and this is the angle which is the positive. But this one 2i along x-axis and 3j along negative y-axis. So the resultant will be like this one, and this angle will be negative. Okay, so the direction going to be changed. So this will affect the direction. Actually this minus plus will affect the direction. Magnitude not going to be changed. Here the length of this vector and length of this vector remain same. Okay, my dear students, in hurry up, in very fast fashion, I'm going to give you some question, and this is your homework. Find resultant, magnitude of resultant. Find magnitude of r if the one r is 2i plus 3j. Let me write here that the a, b, the two vector a, b, it is I plus j, c, I plus j plus k, d, 2i minus j. Now the first question, what will be the magnitude of a plus b? The second question, what will the magnitude of b? The third question, what will the magnitude of c minus d? Okay. Fourth question, what will be the magnitude of a plus d minus e? Do we have e? No, we don't have e. Okay. C. The fifth question, what will be the magnitude of 2a minus 3b? 2a minus 3b. What will be the magnitude? Can you note down? These are the questions. Okay, my dear students. So we'll proceed the vector in next lecture, my dear students. So this is all about today's lecture. Thank you very much.